Hello and welcome everybody, this is Roland from graphicinmotion.com and it is tutorial time again. So let's check out what we are going to create together today. In this 4-part tutorial series we are going to create particle trails in Houdini. I recently had the pleasure of creating some awesome motion graphics for a client's enormous LED wall. This experience inspired me to share some simple but valuable techniques to create motion graphics in Houdini. In part 1 of this tutorial series, I will guide you through creating a powerful particle trail setup, complete with customizable controls that can be utilized with any particle simulation. But that's just the beginning. In part 2, I will show you how to transform this setup into a Houdini digital asset, also called an HDA, so you can easily install and reuse it like any other Houdini node. But we are not stopping there. In part 3, we will bring this HDA to life, demonstrating its practical use as we create the dynamic scene that you saw in the introduction video. And finally, in part 4, I will teach you how to render your masterpiece using the powerful Redshift render engine in Houdini. If you want to grab the project file and the HDA, they are available for download on Patreon. A link is in the video description. And now, without further ado, let's jump right into the tutorial. Okay, now let's get started. And as always, we create a geometry node at first. And this will be my particle trails basic setup. So let's name it and let's dive inside. And first of all, I want to create an emitter for my particles and I will use a circle for that. So let's create a circle. We can use a primitive to do that. And I just want to lay it flat in the scene on ZX for now. And I want to make it a little bit smaller. So let's just make it a tiny bit smaller, like so. And now I want to emit particles from this circle, so I can add in a pop network. Just a standard pop network wired in the first input and activate it. And you see by default, the pop network is already emitting particles. If you press play, there are more particles emitted. Now let's dive in there and let's give them some movement. So we can use these attributes here on the pop source node. Here you can either choose to use inherited velocity or to set an initial velocity. And I want to set an initial velocity. And in our case, let's just zero out the x values here on velocity and variance. Let's put the velocity on y to a value of 2 with a variance of 1. That's fine. And let's also zero out the variance on z. Now we will get particles that fly upwards, and they do this with a little bit different, a bit of variance in their speed. So that's fine. But these are way too much because then we cannot really see the particle trails that we will create in the next step. So let's turn down the constant birth rate to about 15. Then we only get a few particles that will fly upwards. Okay, so that's it. That's all we have to do for now in our pop network. So let's go out of that. And now I want to create the particle trails. So I want to use a trails node. Let's apply the trails node. And you see by default, it only creates particle trails. So now it is set to a length of 2. If I set it to a length of, let's say, 25, then this will be a little bit more obvious. So each frame for 25 frames, it will create a particle that's following the first one in the movement, as you can see here. Now these trails are of course not primitive, so they are not connected. They are only points. If you take a look here, these are just points. Now, if we want to connect them, we have to use an add node. So let's add in the add node. And with the add node, you can add points to your scene, but you can also do other things. So if we activate this for a moment and go to polygons, here we have this by pattern or by group. And in this case, I want to use by group. And if I just switch it to by group, you see already now my lines are all connected. And this is already pretty cool, but it's not a particle trail. And that's because it is now connecting all points. But I want to connect only points by an attribute. So we choose by attribute, and the attribute that you can use to connect these lines is the ID attribute. So you can type in ID, and now you see that we have lines that are only connecting the trails that come out of our pop network, or of our trail node in this case. And if we take a look here at the primitive numbers, you see each of these is now a primitive and has its own number, and that's pretty good. That's what we want. Now, if you only want to have very simple particle trails, then you're already done. But I want to show you a few more tricks that you can do. For example, what if you want to create trails that have different length? Right now, the length is specified by this value here, so the trail length. So this is the overall trail length. And now we can, with a little bit of VEX, we can actually create random length of our trails. So let's do that. But before we do that, I want to create a curve view attribute. So let's add in a resample node, and I'm sure that you already saw this trick. So if you want to use the resample node, and I do not even want to resample these right now in this step. I could do it, but it's not really necessary. You see, it is already resampling it because this is turned on, but I could turn this off for now because I don't need it right now. I only want to calculate this attribute here, the curve view attribute. So activate this here, and then you have the curve view attribute. If we visualize this for a moment, so let's go to the curve view here and visualize this, and let's turn off these points. This will add a value from 0 to 1 along the full length of each of our trails. So as you can see here, it's adding this value. And we can use this value then to create a variation of different, or to create random length of our trails. Good. I will just rename this to set curve view, because that's actually what this is doing. Just set curve view. Okay, now we will create a point wrangle. And this is probably really the most complicated part of this tutorial. So it's really straightforward. And here we just have to do a little bit of coding. Now, first of all, I want to create a random number for each of these primitives. So for each of these lines, and let me actually turn off this visualizer for now again. And then I will just compare this to our curve view, so to the value between 0 and 1, and delete some points. So we will type in here if, parentheses, curve view, and actually I have to say that this is an attribute, so at curve view, that's important, and I always forget it, is bigger than, and now let's create a random number based on the ID of our primitives, so random number at ID, and close the parentheses, and now curly brackets. Then we want to remove point, and we can use this function here, remove point, from our stream number 1, so this is input number 1 here, and then we want to remove at pt num, so the point number, whatever it is currently calculating. And now we can end our curly brackets, and this should already, oops, sorry. And you see this is already working, and now our trails have different sizes, different length. What if I want to have more control over this? So now I cannot even adjust anything here. It is just based on a random value created based on the ID. What I could do here is, first of all, I could introduce a seed, and therefore I want to create an integer variable. So let's choose integer and call it seed. And this is an integer slider, so channel integer, which I also call seed. And that's it. So let's create this slider. And now we can set up a value here and then just add it to our ID, because then we will randomize this with our seed, like so. Now if I change the seed, you see that the distribution is changing. Cool. But there's still not a lot of control. I also want to be able to control the minimum and the maximum length of these trails. So how can we do that? And we can actually do that the following way. We just have to apply or just add in a variable for the minimum length and the maximum length, and then we can fit this together with our random number here. So let's do that. Let's create a float. This will be our minimum length, and this will also be defined by a slider. But in this case, I want to use a channel float slider, so a float value, and call this just minimum, like so. That's it. And then we can just copy this here, this line of code, and call it maximum slider and create this maximum slider. So let's now create these two sliders. You see now we have the minimum and the maximum slider. I will put in some values that these do something here. These are actually multipliers. So these will actually multiply with the trail lengths that we set up here on our trail node. And you will see this in a moment. But now we have to get it somehow into our code here. And to get it into our code, I want to use a fit 0,1 function because I want to fit the number that we have here to a value of 0 and 1, because this is actually what our curve U requires, because curve U is also between 0 and 1. So I use fit 0,1. And now I want to let me take a look here so that I make this the right way. Yeah, here exactly. I want to put in our minimum and maximum value. So here I can put in my minimum value now and my maximum value now. And then I think I have to close the parenthesis one more time again. And now this should work. So let's take a look what we have here. So now if I change the minimum length, you see that it is actually really changing. And if I change the maximum length, this should also work. So now I can really specify the length of my particle trails, and I have full control over it. So that's pretty cool. And you will also find this code here in the video description, or maybe I also write it into a comment so that you can just copy paste it and that you don't have to type it in yourself. Okay, so this is working, and let's call this set random length. That's okay, set random length. And we can also colorize this so that we know this is an important node where we can change something. We can also colorize this one here, because here we can change the overall size. So you see this one here changes our minimum and maximum length, but if I change this overall size, then this still has a huge impact on the look of our trails. Okay, so right now we only have these lines, and I actually can render these lines, for example, with Redshift. You can render it as strands or as cylinders or different methods here, but I do not have any p-scale applied to these lines here. And if I use a sweep node for a moment to make these or turn these into geometry, let's use a sweep node down here, activate it, and choose instead of surface shape second input cross, let's use round tube. And now you immediately see what I have here. So let's invert the cross section because the normals are inverted here. You see I have no scalar value, no p-scale along these lines, these trails. Of course, the sweep node has an option here to apply a scale along the curve, and I could use that to bring it in, as you see here. But if I do not want to use geometry to render, if I only want to use the hair renderer, for example, then I want to have my p-scale written to these trails. And that's what we are going to do now. So let's make this visible that we see what we are actually doing. So now we will use another wrinkle here to create our p-scale along the length of our trails. So let's add in another point wrinkle. Point wrinkle. And now let's type the following code. So at p-scale should be, I want to use a channel ramp here this time. And this is called the thickness. And I want to run this, map this over our curve view attribute. So let's run this again over our curve view attribute. And I also want to have an overall scale multiplier. So I will just multiply this with another channel float in this case, and this will just be our scale. And let me actually press Alt-E here to make this big so that we can see what's going on here. So channel float scale, of course I have to close the parentheses here. And then I just can apply an accept and create both of these controls here. You see I have my scalar now. Let's set this to 1, and then I have this thickness here. And what's happening now, you see it's pretty similar than we had it here with this ramp. We can actually turn this off now. We have now our own creation. And this is not only working with the sweep, this is now also working when you're using, for example, the Redshift hair renderer. Now let's set this up that this makes sense. In the beginning, we want these to grow a bit faster, and then they should stay thick, and then I want them to get thin again, like so. And now we can select all of this by holding down Shift, and we can apply another interpolation. Well, let's do it right here because then you can see it. And I want to use this Catmull Room for now, or Catmull Rum, it's actually called. And then I can just scale it down to 0.01, and then these will be very thin. Maybe this was a little bit too much. But right now you see now I have these thin lines. And they are geometry, of course, because of our sweep. But if I turn this off, now the p-scale is actually really written into these lines. And this is what the renderer will read out and will display. So let's call this here set p-scale. And we can also colorize this red for now, because then we know there are some important things going on this one here. Now, there is one problem. If we take a look again at our sweep, and let's make this bigger so that it is a little bit more obvious what's going on here. If you take a look here at these lines, at a certain point, for example, right here, it's not tapering down in the end. It's just being cut off here as well. Some of them are tapering in more in the end. Why is that? That is because our curve view is actually calculated over the whole length of our trails initially, because it's calculated right here, so at this point. But then we are removing some points, but the curve view value will just end there. So if you take a look at the curve view value down here, let's do that. Let's actually take a look at the curve view value. Let's visualize this. You see that they do not end with a value of 0, which would be red. They are just cut off wherever we remove the points with our wrangle. We can create another curve view attribute by adding in another resample node. So let's do that. Let's add another resample node and put it in before our set scale attribute wrangle. And now we will again calculate the curve view, but this time we call it curve view 1. Now we have two different curve view values. The first of them is controlling our set random length, and the second one we can use to specify our p-scale. So let's do that. Let's go into our wrangle again, and instead of curve view, I can now, now I entered it, I don't want to enter it. I can now just put in here curve view 1. And if I do that, you will immediately see now they're tapering down over their full length. So now we have two options, and yeah, you can change this anytime, however you want. So now you can come in here and decide whatever you want. You can use curve view, or you can use the curve view 1. But of course, it makes a little bit more sense to use curve view 1. So let's turn off our visualizer and let's bring down the size of these again so that these are nice and thin. Okay, so this is basically it. Now we have a very flexible setup that we can apply to any pop network, and we will create particle trails, and we have some pretty cool controls here. Another thing that we can do is that we really resample them, because right now this one here we only used to set the curve view attribute, or to calculate it actually, and this one here we can really use to resample them. If you take a look now, there are not that many points, and if they are bending, for example, and we can do this in the next step, we can take a look at that, it's probably better if we resample them. So before I'm talking here, let me show you this. So let's add in a point VOP here, and let's just add in some displacement, some noise. So let's activate this and go to our enter it. And I will just give myself a little bit of room here. Now we can use, for example, an anti-aliased noise. And we want to do the following. We want to connect the B to this position input here because it requires a position input. Then we can add this to our current position of our points, like so. And add this in here. Now we are adding these two together. And if we go up here and change this noise here from 1D noise to 2D noise, now you see we have some displacement going on. And if I make this a little bit smoother and play this now, you see what we have. Now these are flowing through our noise field. And yeah, that can look quite good, but you see also that we do not have enough resolution on our points, and that's why I said we have to resample them. So now we could do this before here with our resample. Just take a look how much we need, maybe 0.05 and then change this from straight edges to subdivision curves. And now we should get some nice and smooth lines. Yeah, this looks already way better. So this way you can add in some displacement to these straight particle lines. There's another option that I want to show you. For example, if you want to map this noise now over the age of your trails, so the older or the longer they're traveling, the more the noise will change them. And this is also very simple. What we can do here now is that we use a ramp. And that's actually now really similar as what we did in the VEX wrangles before. So now I'm doing it in VOPs. And yeah, VOP and VEX is more or less the same. It's just visual language. And here we can take our age. And before we bring it into our ramp, we want to make sure that we fit it, because it is actually, it should be a value of 0 to 1 if you bring it into your ramp. Now let's change our ramp from a color ramp to a spline ramp, this one here. So let's take a look what values we have to put in here. So what is the maximum age that we want to take into account? And let's say that we want to take into account about 4 to 5 seconds. Yeah, let's say we want to take into account 5 seconds. If you take a look at the geometry spreadsheet, you see the age is right here. And you see that the oldest ones are now 5 seconds old and the youngest ones are just born, so they are at 0. So this is the range that I want to influence, and we can set this now, the source max, to 5, and we remap this age here to 0 to 1, feed it into our ramp, and now we can multiply it with the output of our add here. So let's put in a multiply right here, and then bring in the ramp, and that's it. Okay, let's go back to our scene view. Now we can set up our ramp here. You see in the beginning, there is nearly no influence, and then over a certain amount of time, we can grow this influence, and we can even do it like this. And now we can maybe change the interpolation here to something like that. Then we have a smooth transition here. And you see that now, okay, there's one strange thing happening, and that is now that everything is moved to a point in the middle. And that is actually because I actually linked this up the wrong way. I want to multiply it, of course, before I add it to the current position, because otherwise I am multiplying the position with null or with 0. And then, of course, everything is put into the center. So that's not what I want. So this is the right way. Do it the right way. We'll just put this in here, and this in here, this in here. And now this should work. So now I'm adding the position value that I get out of this calculation after I apply the ramp. So after my multiply. And let's link this up also correctly so that this looks nice. And this is a bit understandable now. So this is what I wanted to do. You see in the beginning now, these are not deformed by the noise, and when they approach a certain age, like here, then the noise will have full effect. So this is just a small example of what you can do with these trails, and yeah, that's what I wanted to show you. Another thing that is cool, if you want to use different colors, for example, along the length here, you can put in a color node and add it in here. And then you can say, I want to colorize these a ramp from attribute, and I want to use the attribute, and that can be curve U or curve U1 in our case. And then you see they will be colored from black and white over the whole length. And of course, you can use this later on for shading and give them different colors. Okay, so this is it with this part. In the next part of this tutorial series, I want to show you how you can create a simple digital asset out of this setup that you created now, that you can then reuse and add to any pop network that you want. So thank you very much for watching, and I hope to see you in the next part.